Now, this is a very interesting project scenario, and the solution of this scenario is used mostly when you're looking for decoupled components, and in case of changes and new modification, you only want to modify concerned areas and not the full application. So what is this scenario all about actually? The scenario is very simple. It's about a tax calculator application. Now, this tax calculator application is famous across South Asia for doing tax calculations. It's a Windows based application, and for different regions it has different tax calculation logic. So when you execute the application, it will tell you that please select your region, and once you select the region, then depending on what region you have selected, the appropriate tax calculation logic will be executed. And the final important point is that the complete architecture of this project currently is based on factory patterns. So let's talk about this point number 4 more, because that's where our problem actually revolves. The complete solution or the complete project is divided into 4 projects. The first one is the user interface, the Windows application forms and your buttons, your text boxes, everything actually comes in this project. The second project is the interface. Now, this interface project actually it's nothing but it's a simple .NET interface which actually helps you to communicate with the concrete classes or with the actual implementation, and the actual implementation is a different project altogether. And then there is the fourth project is a factory project which actually creates this object of this concrete classes and gives it back to the UI, and this UI actually talks via the interface. So there are 4 projects in this solution, in this application. First one is a user interface, which is basically the Windows form. The second one is an interface, a .NET interface which talks, which talks with your concrete classes. And then the third project is the concrete classes itself. The implementation is actually in this project. And then you have a factory project which actually helps you to create the objects. In other words, all the new keywords are here. So they help you to create the objects and give it back to the UI. So here's how exactly the project looks with the code. So this is the first project you have, that's your user interface. Then you have a second project which has the interface iTax, and it has 2 functions. One is the amount and the other one is the calculate tax. So basically the amount will take the value, like for whichever amount you want to calculate the taxes, and the calculate tax will actually return the tax as per the amount which is provided. Then you have one more project which is the factory class. Okay. Now this factory class, what it does is it takes an integer value, must be 1, 2, 3, 4, whatever it is. Okay. And depending on what integer value you have provided, it actually creates the appropriate concrete objects, concrete classes. Okay. So this is the third project, and the final project is our actual implementation. So for each region, what we have done is we have created different tax calculation logic. For example, we are saying, okay, tax India Delhi. Okay. So the tax India Delhi calculation will have all the logic which is pertaining to tax calculation regarding to India Delhi. Then we have tax Nepal Kathmandu. So any kind of calculation logic as per Nepal Kathmandu will be done in this class. So these are all concrete classes. So this is one more project. The actual logic actually lies in this project. So the user goes and he selects a combo box. Okay, let's say Nepal Kathmandu or whatever it is. This request is then sent to the factory class. The factory class takes up the value from the combo box, whatever it is, goes and creates the appropriate object and sends it back to the UI, and then basically goes and invokes the logic. So in other words, this architecture is very nice architecture. Why? Because the UI and your concrete classes are completely decoupled from each other. So there is no connection directly. So in other words, if I change this user interface, I don't need to really think about any changes in the classes, as well as vice versa. Tomorrow, if I add something over here, I don't need to worry on the UI part. So this is a very pretty decent architecture which currently the TaxCal application is following. So, let me just run you through the source code also so that you can understand better the architecture. So here's the solution. You can see that there are 4 projects here. The first project is a user interface. So you can see that the tax calculator is the user interface project, which has a simple form which actually helps you to enter the amount and hit on the calculate tax button. The second project is the interface. So basically I talked about the .NET interface, which is a simple interface which has an amount and a calculate tax function. The third project is basically our concrete classes. So for each of the regions we have created different classes. So you can see that There is CLS tax India Delhi, which actually implements the I tax, and it has a calculation logic here. Then we have CLS tax Nepal, which again does the calculate tax here, and so on. So this tax calculation is actually a concrete project. And then we have one more project here called as factory tax. This factory tax is a person who actually takes up an integer value and gives back concrete classes, right? So we have 4 projects. One which basically implements the factory pattern. The second one, an interface which connects the user interface and the concrete classes so that they do not talk with each other directly. And the final one is our Windows form. Now, one good advantage of this architecture is the user interface, right? The tax calculator user interface. If you go to the references, it only refers the interface and the factory pattern class. Okay, the factory class. It does not reference directly our concrete class, that is tax calculation, which actually has a logic. Okay, so if you see here, this is my tax calculator project, which has FRM tax and FRM tax calculator. You can see that it's only referencing factory tax and I tax. It is not referencing my concrete project. So in other words, this architecture is good. Why? Because tomorrow if I go and add a new class here, I don't have to make too many changes across the project. Okay, so let me run this application and let me show you exactly how it runs. So I put a debug point there. So let's see exactly how the whole thing actually works. So let me just put some debug points at appropriate places, right? And let me run this application. So there it has hit the debug point. So the first thing we would like to do is we'd like to fill a combo box or a list box or whatever it is, from where the end user can select and tell that from which region he is logging in from. So you can see that I am filling up a combo box here called as CMB regions, and over there I'm filling the country as well as the state or the sub-region, so that I can calculate the tax as per the country and the sub-region. So there I go and fill my combo boxes, and that's my load region, and that's what I have. Now let's say I go and select India Delhi. Now you can see that basically it has fired my combo box change event, and over here what I'm doing is whatever is the region selected, right, the selected index, I'm passing up to a different form called as FRM tax. Now this FRM tax actually is the main form where you are going to enter the amount and hit the calculate tax button to get your tax calculations. So let me go and invoke this form here, and let's say F11 show dialog box. Now I'm inside the second form, that is FRM tax.cs. Now you can see over here what he is doing is whatever region which I provided right from the first screen, it's actually taking the region value and going towards the factory class and telling the factory class to invoke the appropriate object. So if I do a F11, it goes to my factory class. The factory class actually takes whatever value it is and then invokes the appropriate concrete classes. For example, now I have selected India, so you can see that basically he is going to select CLS tax India Delhi, right? But when this object is returned back, he is going to return a I tax, so that the form as well as the concrete tax, that is CLS tax India Delhi, CLX tax Nepal, Kathmandu, etc., is not in direct contact with the user interface, so that whenever you add a new class, a new implementation, the UI doesn't have to change. So he typecasts these concrete classes to generic interfaces so that the UI and the concrete classes are decoupled from each other. So I go back from here, F11, and now there I am on the form. Now this form, what you see over here, is pointing towards CLS tax India Delhi, right, the concrete class. So let me just put 12 here and hit the calculate tax button. Let me put a debug point here also in the calculate tax button. So there it goes. Now my interface, right, is actually pointing towards CLS tax India, you can see, right? So he will go and invoke the CLS tax India logic. So you can see that basically he has gone and hit the CLS tax India class, and the CLS tax India says that for India it is 15% tax. So he returns back me the value, and that value is displayed on my combo box. So you can see the value is this. Now if I go and select some other region, let's say I close all this, let me just go and run this. Just close this. Now if I go and select, let's say Nepal Kathmandu here, again it will go and invoke the appropriate form. It will go and tell to the appropriate factory that please go and create the concrete object of CLS Tax Nepal. So that will go and invoke CLS Tax Nepal, and then when I type, let's say 11, and I hit calculate tax, it will actually go and call the Nepal tax calculation logic. So you can see that basically now, because I've selected CLS tax, the tax calculation for Nepal Kathmandu, it is now going and hitting the appropriate appropriate implementation, and that's my display. So right now, if you look at the architecture, it is pretty sound. The user interface is talking to the concrete classes via interfaces, and all the creation of the object is handled by the factory classes. So really this is a nice architecture. It is decoupled. So the next question is, what is the problem with the architecture, and what exactly are we expecting, or what are we trying to improve in this architecture? Now the architecture is pretty decent, and personally I like this architecture. It is factory pattern implemented, it is decoupled, the UI is talking via interfaces, and the object creation is centralized, etc., etc. But I would like to do a couple of improvements here. The first improvement is that, as I said, that this application is installed across South Asia in different regions, right? So what I would like to do, what I would like to do is improvement number 1. Currently, all the logic is going into only one DLL called as tax calculation.dll for now. Okay. Now what I would like is, if let's say this installation is happening in some Indian user desktop, I would like to see a view something like this. He should only see logic which are pertaining to his region. For example, now this is a typical installation which is done in an India location, on an India location for this tax calculation application. So I would like to see DLLs only related to that region. I don't want to see here tax Nepal Kathmandu or tax Bhutan or something. I would like to see only tax India Calcutta, tax India Delhi. So logic which are pertaining to that region should only be shipped with the installation and not the other DLLs. That's the first improvement I would like to bring in this application. The second improvement is, now if you see, let's say that when we want to implement a new tax calculation logic, we have to change in 2 places. The first one is we have to put an extra if condition in the factory tax.dll. The second one is in the tax calculation.dll, we have to add the extra class. Now I would like to make change in only one place, at only one place. That means, like for example, if I'm going to add a new tax calculation logic like tax India Mumbai, right? I'll just paste that DLL and I will make a couple of changes in the app config file and it should work. I don't want to change, any more DLLs. So I want to make only 2 changes. Again, when I say the second change, it is related to the app config file. So what I would like to do is, I would like to remove this factory pattern from here, or the factory class from here. Okay. And I would like to do only one change, that is paste the appropriate DLL, which is either a new one or updated change, and then go and make some changes in the XML file, and the application, your exe, should just consume this new logic. So let's summarize our end goal, what we want, from this current architecture. First, only the necessary DLL should be shipped to the necessary regions. So one region of one DLL which belongs to some regions should not be unnecessarily shipped to the other region. That's the first thing. Second thing, there should be 0 changes in other DLLs and exe. So in other words, whatever new logic you have added, that is fine, but other exes and other DLLs should not be touched. In other words, I want changes in only one DLL. Okay, like in the current architecture, we are changing the concerned logic which is there in the DLL, and also we are changing that factory DLL. So we want to get rid of that factory class from there. That's the second change we want to implement in this project. And the third one is, the configuration should be via XML files, or some kind of app.config or some kind of XML file. So that's the end goal of this application, what we want to achieve from the architecture perspective. And while we are trying to achieve this end goal, we want to use solutions which are industry standard. For example, for this, I don't want to use reflection. I do understand that reflection is the best way, just paste the DLLs and it will go and invoke the DLLs on runtime, but we don't want to use reflection for now here. So we want to have a solution which is standardized in the industry, right? So let us know what is the best solution for this problem. And second, I want to just give you a hint. The way to think solution for this problem is that the task creation which is happening currently, inside the factory class should be inverted to a external framework. That's a hint over here. So I hope that you can find the answer for this solution. If not, then, do see our video, which provides a solution for this problem. Thanks a lot. Thank you very much.